Welcome back. Today we're going to be looking at some cool stuff in Python. So based on what we've learned, kind of nothing that you see in this lesson is going to be new, but it is going to be useful and hopefully it will improve your programming format as well as style. So the first thing I want to look at is yield. And I like of thinking as yield as kind of a sweet dispenser where you keep just dropping one out until you're all done. And so if we take this function, which is a generator, it just loops through all the values from 0 to x, and then it puts them in this list result, and then it returns it. But with yield, we can just yield I times I. And this is really nice. Also, it gives us back a generator object, but we can easily convert that to a list. So here we've got an example with the Fibonacci numbers. So we have a list that has the first two, and then we loop through all the numbers up to n minus 2 because it generates the first n, and we've already got 2. And to the end we just add on the previous one plus the one before the previous one, and at the end we return this list. So there you can see we've got the list of the first 10 Fibonacci numbers. And then with yield, this time we've defined n1 and n2 as 1 and 1, this is what the commas do. And then we yield n1, which is the first number, n2, which is the second number, and then again we do n minus 2 values, and we set m1 to n2 and n2 to n1 plus n2. And this is done using temporary values, so you don't have to worry about the fact n1 is updated before n2 is. And then it yields n2, which is our new number. And you can see that this creates a generator object. So if we just convert that into a list, you can see we've got the Fibonacci numbers, which is very nice. Next is single line statements. And so if we take this example of a step function, then if the value is less than 0, you return 0. If it's more than 0, you return 1. But if it's exactly equal to 0, you return 0.5. So we can print out the steps of all these values, and they're 0, a half, and 1. But then we can change it so that it's now shorter. So instead of just putting the new lines in, because this is a single statement and it only works with single statements, we can put it after the colon and on the same line. And this is quite useful if you want to do maybe a pass, because nothing else is going to go there anyway, and you can see it works the same. And then this is an even nicer way of doing it. So we return 0 if x is less than 0. And then otherwise, so else, we return a 1 if x is greater than 0, otherwise 0.5. And if I highlight that bit, you can see the format of the if statements. It's value if condition, otherwise other value. And you can see in this bigger structure, this just makes up the else bit of the previous one, so you can keep chaining these together. It's also important in these though that you do have an else. You can't just have an if. You can see again that it works. Then we'll look at single line for loops. So here's squares, and this just prints the square numbers, and we can run that and you can see that we've got all the square numbers because it's converted the thing we've generated into a list, and we've got our yield statement there. We can also do this, and if we run that, it's going to give us the same thing because we've got this colon, we've got a single line, so why not put them on the same line? But here we've got something quite different, and this returns a list rather than a tuple. And so we're saying this is the value you want for each I in your list, and this is 1 more than I squared. And so this is our iterator where we keep looping, and this is the value we store in the list. And so we see the first 10 squares again all printed out. And this has another quite useful use, I say, is if you want to define an empty list, then you could do this. So we've got a 1 repeated 4 times, all repeated 5 times. So this is a 2-dimensional list. and then we print it, and then we change one of the values. But you'll notice even though we've only changed this value, all of these have changed because we've got duplicated lists. And so to fix that, we can just return a 1 for iron range 4, which is the size of our inner loop, and then we can do this 5 times for our outer loop. And this time when we change it, we can see that only one value has been changed. You might think, well, we could also, if we want to print all the values I and j, we could put everything like this, where we've got a for loop and then a single statement, and then a print, but unfortunately we can't do that because you can only have one colon per line. Another thing most people notice quite early on, especially who've done other languages, notice in Python you can't have multi-line comments. So we take this, we're saying what our step function, which we saw earlier, does. You see it's only got, 3 individual lines of comments, and if we wanted to delete those, we'd have to uncomment them out individually. Although in VS Code you can use Control/, which is quite nice. And so we can define our step function like that, or we can define it like this. And here we've got 3 quotation marks, and this is now a multi-line comment. And one of the advantages of using the 3 quotation marks is that we've now got a help. So if we run this, you can see it says the help on the step function in module main. It says it takes in a single value x. If x is less than 0, it's equal to 0, gives you 0.5, and if it's greater than 0, it gives you 1. And that's exactly what we've written here. Whereas if we did it here, it wouldn't work. Another thing is multi-line definitions. You've seen that you can define a list on multiple lines, or a dictionary, and some other data types. And there we've got, a chessboard maybe, defined on multiple lines. And then here, we've got a long string, and we're going to imagine this is an incredibly long string, and you want to print it on multiple lines. Well, you can just put the slash in there, and then when we take it out at the end, it's seen that you don't want a new line here because you've got this backslash, and so it lets you keep the string without any line breaks. And you can also do the same with sums, for example, or addition. Instead of writing everything out on the same line, we could just put a line break in here, and we can go on to the next line. And you'll see that it's worked out, and our large sum is 55. It hasn't cut off any of these values or anything. So these are some really useful tricks that can make your code neater. They're not huge for increasing functionality, but they're nice things to know, and you can do some cool stuff like convert very long functions into a single line, which I really like. So hopefully you've enjoyed this video, learnt a lot, and I'll see you again same time next week. Till then.